sharing my screen, and at this moment you should already be able to see my virtual PC and my presentation about temporal data in SQL Server. If everything is all right, I don't need a feedback, but if you can't see, maybe somebody can turn on the microphone and tell me. Okay, since there is no feedback, I guess everybody sees everything. So I will talk about temporal data in SQL Server, a brief theoretical introduction, and then a quick overview of SQL Server system version or temporal tables. So first, a little bit of introduction from the theory. This theory about temporal data was developed mostly in 90s by Chris Date, started already in 80s. Chris Date, co-worker of code. So it's pretty long time since everything is known, but we will see which part is implemented in SQL Server. So what is the problem? In many typical relational databases that support line of business systems, we can see current state only, like that there is only one time point in the world, and this is time point now. And we pretend that constraints that we have are valid in present, past, in future time, or valid forever. And example, we have suppliers and we have contracts, and we have the fact that supplier is under the contract, and we many times pretend that this supplier is under a contract from the beginning of the time and will be under the contract till the end of the time. On the other hand, temporal databases hold time-stamped propositions, so propositions that have some validity period. And we can express these time-stamped propositions with a couple of predicates. Since predicate is from some point in time and not immediately before. On the other side, time is not limited. We could also define up to some time, but usually we need only since. So we have interval that is closed on one side and open on another side. And then we have completely closed intervals during, so or from to. This predicate means that this proposition, row, or tuple in our relation is valid only throughout this interval, not immediately before and not immediately after. So supplier A is under a contract from time point A to time point B. We represent time with what we pretend to have distinct time points. And we know that time is continuous, but we work like time would be a countably infinite set of distinct time points, and granularity depends on our needs. We can measure time in days, hours, seconds, months, years, whatever we wish. Each this time point is for us in our business system indivisible. However, this time quantum is actually a small interval. Because we are working with countably infinite ordered sets, we can always represent time points with integers. It's always possible to transform them to integers. Now, what are the problems with temporal databases? First, let's start with semi-temporal. So we have predicate since. So we have suppliers, and supplier 1 is our supplier since time point D04, supplier 2 since time point D07. And then we have suppliers parts. We see that supplier 1 is supplying part 1 from time point D04, etc. There is no additional problem compared to non-temporal databases with keys, so we can use the same primary keys and foreign keys. What we need is only a single additional constraint. No supplier can supply a part before the supplier is under a contract. So, for example, supplier 1 shouldn't be able to supply anything before time point DO4. By the way, just worth mentioning, do we use open or closed intervals? Because we are working on countably infinite discrete set, it doesn't matter. It's just a matter of choice, whether the borders are included in the interval or not. But from a mathematical perspective, this is completely equivalent on discrete sets. Now, full temporal problems are a little bit more complex. So now we have this situation. We have suppliers, and we have supplier 2 that was under a contract from time point 2 to time point 4, but then also under a contract from time point 7 to time point 10. And then we have suppliers parts, where we have, again, interval during which the supplier supplied the part. For example, supplier 2 supplied part 2 in the interval from time point 9 to 10, but also in the interval from 3 to 3. Now here we have many additional problems. First of all, what is a primary key here? Basic primary key supplier ID in the suppliers table, supplier ID part ID in the supplier's part table cannot be primary keys anymore because they can be duplicated. So we have two candidate keys which are both composite. In suppliers, we can have supplier and from, or supplier and to. In suppliers parts, we have supplier ID, part ID, and from, or supplier ID, part ID, and to. So we are breaking the Boy's code normal form. How could we solve this problem? Well, we should simply join from and to a single column interval. So we should support interval data type in our database. The next problem, 2 should not be less than from. Okay, this is simple, a simple check constraint. Or if we implement an interval data type, with this data type should implement also this constraint. And then we can add many additional constraints. So for example, we cannot have a situation that a supplier ends contract on one time point and immediately after starts a new contract, let's say with the same terms. So for example, we wouldn't allow in supplier table supplier DO2 to DO4 and then DO5 to D10. This should be unioned to a single row. And also no overlapping of intervals. We don't want to have a supplier under two distinct contracts on the same time point. And as I said, these are optional constraints. Please don't jump and say, but yes, we can have this in our situation. I'm talking about optional constraints. Also no abuting, no overlapping. And yes, no supplies if supplier is not under a contract. But now we have an issue. Also, foreign key cannot be that simple anymore. We cannot just use foreign key from supplier's parts on supplier ID only because it is not constraining enough. Let's say supplier 1 was our supplier from time point 4 to 10. If we would use just supplier ID as the foreign key, we could insert a row in supplier's parts like S1, P1, DO3 to D10, but supplier cannot supply anything if supplier is not under a contract. So we should have something stronger than foreign key, and we can call this inclusion dependency. So the interval from the supplier's part table must be included in the interval, at least one interval from the supplier's table. So for example, for supplier 2, we have two possible intervals. So any row in supplier's parts should have an interval that is included in intervals D2 to D4 and D7 to D10. And you see, this is what is needed for full temporal support. Now, what I talked about so far are valid times, but we can also measure or store in a database transaction times. So when did the transaction happen? And temporal databases could support valid and transaction times. Valid times are our times, and transaction times are database times. Definitely, valid times are more important, and you will see also much more complex. Why are they more important? I mean, who cares exactly when did you insert the contract for a supplier? As far as it was inserted before the contract really started, the really important part is since when the contract is valid. Anyway, valid times are updatable because you can make an error, you can change a contract. However, transaction times is something that cannot be updated. This is exactly the moment when transaction happened. And of course, in our logical model, from business perspective, transactional times are not that important. But of course, who knows this or what system does know these transaction times? Of course, this is our relational database management systems. So the only logical conclusion is that transactional times should be measured automatically and inserted automatically by relational database management system. And support for valid times would also be appreciated. And now enough about theory. Now let's see what is implemented in SQL Server. And I am working with Microsoft SQL Server since 1992, since SQL Server 4.2. And in this nearly 30 years, what I noticed is that, and probably not just with SQL Server, but also with other products, Microsoft is very keen on shipping semi-products and never finishing them. And with this temporal support, what we have is support for transactional times only. There is no support for validity or valid times. So any solution for valid times must be custom made. After all of these years, still no support. Support for temporal, for transactional time, this system version tables came with SQL 2016. And then it was a little bit upgraded with 2017. And then seems like Microsoft has found new toys. So apparently it is not the focus of Microsoft to support validity times anymore. Maybe they have now focused more on other things that are fancier these days. Anyway, at least these temporal tables, system version tables are implemented. Some things are implemented nice, some things are not implemented in nice way, but I will go to more positive side, not COVID positive, but psychologically positive side. So I will stop talking about bad things here and we'll go just to what is nice with these tables. The nice thing is that it's implemented in such a way that you can do everything you need also on existing tables without any change in application. Even if application is written poorly, for example, even if application is using query select star, you can still implement system version tables in your database and you immediately follow the history. So all of the history, all of the old versions of rows go to history tables. So each current table has also a history table if it's marked for temporal support. By default, the history table is, if you leave SQL Server to create it automatically, is a row store table with a clustered index on the period columns. Yes, we use 2 period columns, from and to. I mean, name of the columns is up to you, but data type is limited to datetime 2, and you connect them into what is called period. Not really full interval data type, but at least these 2 columns are somehow connected. The limitation datetime 2 is, I said I will be positive, but sorry, it's another bad thing, because datetime 2 can have the granularity from 1 second up to 100 nanoseconds. If you have need to have granularity, for example, on day level, you cannot implement it out of the box. Again, you need to use a custom solution. The table must have primary key. The historical table cannot use any constraint. And if you create history table by yourself, you can use any kind of name, not automatic name, any kind of storage. You can even use columnar storage. Otherwise, default history table uses page compression. The history table must reside in the same database. And once the history table cannot have any triggers or any constraints besides primary key. And once these tables are connected into temporal tables, you cannot alter or drop them. You first have to break the connection. Once you break the connection, these are regular tables. You cannot use file table or file stream property. Take care if you have large objects in a row, because every update of a row will make a copy and a history table. So history table could start growing very quickly. And you cannot use this start and end time period columns in inserts and updates, which is logical. It's like you cannot use identity, but there is even no way, like with identity, to set identity insert on. This is always forbidden. You cannot modify data in the history table unless you break the connection between 2 tables, as I said, and these are 2 normal tables. You cannot truncate a system version table. Merge replication is not supported. And for the history table, you cannot use change data capture or change tracking. This is only on the history table. You can use this on the source table. So you can have multiple ways how to track his history. And how do you query them? If you don't change anything in application queries are referring to the current table, and it works like there is no history table at all. However, if you want to get data from both tables in a single query, of course, you can always write 2 queries and union this by yourself. But in a single query, we have additional clauses in the from part of a query. And this clause is for system time with subclauses as of. So it means give me the state on this moment. From to or between. The difference from to from between is that from to doesn't include the upper border, while between is using closed interval and also its end time. By the way, in these system version tables, the intervals, these periods from to are open to on the right side and closed on the left. So begin of when you see from 2 columns in a table, from is part of the interval, to is exact 1 time point after the interval. Contained in gives you all transactions, all what was changed in the specific interval. All simply means select everything from current table, union all, select everything from history table. Let me switch to demos. I will start with Wild Word Importers demo database, which has some temporal tables. I'm opening the tables folder and let me use Zoom it. You see that some of these icons for the tables have a little clock on the icon. These are temporal tables. And for example, application cities is a temporal table. If I expand it, I can see that I have application .cities archive table. So this is the history table for application cities table. Now let's check countries. Countries is also system version table. So let's count number of rows from this table, and it's 190. But let's see, this is also a temporal table. So we have application countries archive. Let's check this table, and we have 36 historical rows. Let's use catalog views to check the history table storage. And I see that we have row storage with page compression. I can also use CSSP help system stored procedures to get all of the details about this table. So I see that I have also clustered index on these two columns, valid to, valid from. Please note that this is not really, this is misleading name in this database because this is not validity time, this is transactional time. This is more like known to database from to. Validity time is human. Now let's include also the actual execution plan and select all rows. If I just select all rows from application countries, I still get a regular 190 rows. But if I add for system time all, then you see I got 226 rows. And if I look at the execution plan, I see that I had clustered index scan in both tables, countries and countries archive, and concatenation is simply the union operator. So this is completely equivalent to two queries connected with union, just written in a single query. So let's check what are all possible valid from, valid to. These are these dates. So first rows were inserted in 1st of January 2013, and then first modifications were done on 1st of July at 16. Let's check what was the state on the 2nd of January 2013. So this is for system time as of, and this is the state at this system time. And I see some rows are still valid. Those rows where we have maximal possible date time 2, these are the current rows. And some rows were valid at 2nd of January, but for example, this last but one row was modified on 1st of July 2015, so we know it's not valid anymore. And again, we had clustered index seek in this case in both tables, and then union results. And I can do this also manually with two queries, and I get completely the same execution plan and the same result. Let's explicitly define that I want current rows. So select star from application countries for system time as of now, and now is CCUTC date time, so it's date time 2 actually. Small error. Who wrote this shit? Now let's execute this, and okay, first results 190 rows, so results are actually the same, but let's see the execution plan. Well, this is difference. As soon as I use for system time in my from part, SQL Server goes automatically in both tables, although in this example it was not necessary, so it would be better to use unchanged query, not referring to this time point now. So from to, this is current and historical rows that were valid between these two dates, and I have 190 rows. that were valid. But if you remember, there was a change on 1st of July 2013, exactly at 16. And if I change from to between, then again, I'm going to both tables. But in the result, I get 11 rows also that were changed in exactly this time point to the 1st of July 2013 at 16. Contained in gives me rows with activity in a specific interval. So this was this interval from 1st of January 2013 to 1st of July 2013 at 16 o'clock included. These are exactly these changes. So these are exactly these 11 rows that were changed on 1st of July 2013 at 16 or 4 p.m. Let me create a temporal table manually. So what you need to do is have two columns, which are both datetime 2. Datetime 2 can also, you can define the number of decimals from 0 to 7. 7 means 7 decimals means granularity 100 nanoseconds. 0 means granularity 1 second. So you cannot go below or beyond 1 second granularity. And then this is the full syntax. You must also specify that these are generated always as a row start, and they are not null, and generated always as row end. And now these two columns, we connect them to period for system time, and now for system time closed and work. With system versioning equals on, but I'm not changing defaults. I'm just using my own name for product history, but SQL Server will use defaults. So it will create it will use page compression and clustered index on valid from, valid to columns. What if I want to explicitly define history table? So let's disconnect these two tables. And I can now, when they are disconnected, I can simply drop them. And now I will create explicitly product history table. And in this case, I will use different indexing. Default storage will be columnar storage. And on the top of it, I will have a non-clustered index on product history using product ID valid from, valid to. And now I create table product and check the storage. Of course, I can see now the storage. I have non-clustered index, and I have, which is not compressed, and I have column store compression. I can also use syssp help, and I see that now I have two indexes, clustered column store and non-clustered on this table. Now I said that I could use also select star without a change in application. Let me create another table, simple table dbot1, and insert some values. And this table, if I query this table, I am getting back this new two new columns. So application might get confused if it uses select star. However, what I can do is this. I can add hidden keyword, or this is property of this valid from and valid to columns. So they are hidden for select star, but they are not hidden for explicit queries. So now if I select everything from T2, I don't get these two new columns. But I can always refer to them explicitly. So again, I will just expand this star and add valid from, valid to, and I get also these two columns. Okay, and you see that you really don't need to change the application. Let's try to drop one of these tables, and I get an error, drop table operation failed. I need to disconnect the connection between current and historical tables. No, okay, let me switch for a moment to slides to see where I am. So we generated a temporal table, and the nice thing about this implementation that with hidden clause or hidden property, you can use temporal tables even with applications that are written poorly, that use select star, which we all know that is a very bad practice. Alter table is limited. You cannot do whatever you wish. I mean, again, if you break the connection between current and history table, then these are just regular tables, so you can do whatever you wish, but you should, of course, take care to alter them in the same way, otherwise you will not be able to connect them again. But there are some things that you can do. You can add a new nullable column, which is metadata operation only. You can change a data type or remove an existing column, and system will automatically perform the action against both current and history tables. But please understand, changing the data type has the same limitations as changing the data type for non-temporal tables. For example, if you make a character database shorter and string truncation would happen, then this change will not succeed. I mean, these are normal limitations. Of course, you also cannot change data type from string to integer if you have in strings non-numbers. So these are normal limitations. If you want to add a non-nullable column, then you must provide a default constraint, which means that this default will be propagated to all of the rows in the current and in the history table. So take care, this might take a lot of time. You can also use alter table to add or remove the attribute hidden to this period columns. You cannot add an identity or a computed column, or row GUID column, or change an existing column to row GUID column. You cannot add a sparse column set. Sparse is an XML column for a set of columns, or change the existing column to sparse column. But this limitation is true only when history table is compressed. So by default, remember, we have page compression. If you have this need to use sparse columns, I don't think many of you are using it. I hope you are not using it. Why? Let me explain. And here I am ranting again. I mean, if you use sparse columns, it simply means that you have bad database design. You don't use super and subtyping. So you don't use generalization, specialization. It's so simple, and I will not go into this more in details. But if you use it, search for what does it mean, super typing, subtyping, and change the design of your database appropriately. As I said, if you break this connection between these two tables, alter table set system version in off or false, then we have just two regular tables, so you can do with them whatever you wish, including, of course, dropping them, and also altering, dropping period, but then, of course, you cannot convert these tables to temporal tables anymore. SQL 2017 added a retention policy. First, you need to enable it on database level, and then you configure it on table level. And I will show you in a demo what this retention policy means. The problem with history tables is that rows are only inserted and inserted and inserted, never deleted. A retention policy doesn't mean that some oldest rows are overwritten. It simply means that when you use for system time clause in the from part of the query, SQL Server automatically adds a predicate where clause which will filter the oldest rows that are beyond the retention policy. But physically, they are in the historical table. So how can you get rid of those rows if you don't need them? If you want to clean up the history table, well, you have to break the connection between tables, then delete the rows from history table and reconnect them again. And you can imagine that this is an offline process. You cannot allow users to modify data in current table at the same time. Otherwise, of course, you wouldn't have a complete history. From 2017, we can also use system version tables for memory optimized tables. However, history table is on this table, and this would slow down memory optimized tables if any change would be first written to disk and then made in the memory optimized table. So with memory optimized tables, SQL Server adds a hidden memory history table for the recent changes, and this one is then asynchronously flushed to the history table which resides on disk. And let's see also these demos. So first, let me insert some data. Remember, I still have DBO product is a temporary table. So let me insert some data. I have some data in the products table. History is empty. Let's make some update on product 21 and let's check what happened. So the price is updated in the current table and the old price or the old version of the row is stored in the history table. Please note that valid from in the current table has exactly the same value as valid to in the history table. Remember, we have intervals that are open on the right side. So this one was valid from the current table, was valid exactly from this time point, and the historical row was valid up to this time point, but not on this time point anymore. Let's add a nullable column. Let's add a nullable column. Let's say color and varchar not null, and let's check what happened. This change was propagated to the history table. Let's add a non-nullable column with default. So we have some product category, default 1, and let's see what happened. And we can see that also this change was propagated to historical table as well. And yes, in our tables, we have still these period columns visible, so we can hide them. And let's check now for system time with select star. So there are no valid from, valid to columns. Again, we cannot drop these two tables unless we break the connection between them with alter table DBO products and system versioning equals off. And now we can do whatever we wish, including dropping the tables. Let me also show you the retention policy. So I will set temporal history retention to on for my wide world importers database. I didn't have any rakia this morning yet, so I have problems with long words. Let's create this table, valid from, valid to, date time to, and let's create history table, create cluster at index and populate. I will insert few historical rows. And you see the first one was valid from 1st of November 2019 to 6th of November 2019, and the second from next time point up to 14th January 2021, so up to Thursday. And this is the current row. So let's see what we have. We have one current row and two historical rows. Let's define connection between from and to times. So now we have period, and now I can change these tables to historical. Please note this. Let me again select everything from these two tables. Please note that we must have date times without any gaps. This is checked when you alter tables to historical tables. If, for example, here would be a gap, so this one was valid to 6th of November 2019, 00. Let's say that here would be 6th of November 2019, 000001, and this wouldn't succeed because there are no gaps that altering succeeded. And but I also add another property: history retention period equals 3 months. This first row is older than 3 months. It's already more than 2 years old. So let's select everything for system time all, and you see that I get only the latest historical row, not the first one. With union all, I can still get both tables. So what is the still get both rows from the history, all rows together. So what is the difference? Let's check the execution plan, and let's check the execution plan for the historical table. And you see what I have is I have seek predicate star operator at the bottom of this pop-up window. Operator date add month minus 3. So this is the validity valid 2 must be greater than current date type 2 minus 3 months. So it's just additional filter in the seek predicate, but the row is still there. So let's check the retention period. The retention period is 3 and unit is 5. And here is how this translates to the time units: day, week, month, year. Okay, let's clean up everything. And we are at the end. As I mentioned, there are also some drawbacks. I will not go into details. Those that attended my first seminar, first charity seminar for these victims of earthquake on 2nd of January, I took a little bit more time for ranting. Now, the organizers have limited me to 45 minutes, so my 15 minutes of ranting is cut off in this presentation. I am here. Thank you very much for participating. Thank you very much for donations. I really feel with these people. Imagine how hard it is to lose your home right before New Year, when everybody is celebrating.
Dejan,
Yes.
We have one question. Are the data deleted from the table with retention policy? Maybe you saw or not. Damir asked, so maybe you can.
Yes. I think I mentioned this. No, data is not deleted. It is still there. I could remember when I did manual queries with Union, I could still see it. Retention policy simply means automatically added filter where predicate in our for system time queries. So the only way how you can delete this data is breaking the connection between two tables, delete manually, and restore the connection, which means tables are offline while you are doing this.
Okay, thank you. If you have more questions, just this was eye-opening. Thank you very much. Juro said thank you. Okay, so thank you very much again. Thank you all for a donation. We are continuing for about 15 minutes. A Dejan, mi kad se nađemo, nadoknadit ćemo to.
Znam, čim bude moguće dolazim u Zagreb, idemo u Zvonce ili negdje i to za čitavu noć.
Okay, thank you.
Thank you everybody. Enjoy the rest of the day. Bye.